Okay, hopefully this is working. I'm fighting with recording this on Zoom for some reason. Okay, so we're going to do the baseball problem. Here's what it says. It says at t equals 2 seconds, the acceleration of a baseball in counterclockwise circular motion is 6i meters per second squared. It's moving at constant speed, gives us more information about 5 seconds, and it wants to know the velocity of the baseball at 5 seconds. All right, so here's the deal. So the baseball is spinning. It's in counterclockwise circular motion. So that means it's going around this way. There's some little arrows in here so we can remember which way it's going as we're solving the problem. It'll be important in a minute. All right. Now, what it tells us is that at t equals 2 seconds, the acceleration is 6i meters per second squared, which means it's pointing that way. All right. Now, remember, your acceleration vector always points toward the center of the circle. Okay. And so if this is my acceleration vector and it's pointing towards the center, then it's got to be over here, right? Okay, so that's where our object is at t equals 2 seconds. Okay, and here's my acceleration vector. All right, the next sentence tells us that at t equals 5 seconds, the acceleration is now negative 6j meters per second squared. It means it's pointing down. So that's telling us that now it's up here at the top, right? Because again, that acceleration vector has to point towards the center. All right. Now, it tells us that the period is more than 3 seconds. So what it's saying is that in the 3 seconds it took to get from here to here, it completed less than 1 circle. Oh, so that means in those 3 seconds it went from here around to here. And keeping in mind, I know it's going clockwise, so that's how I know it went the long way around and not the short way around, okay? All right. So let's see. So that looks like because those two acceleration vectors are perpendicular, that means they're a quarter of a rotation apart, right? So that means it looks like this yellow part is 3/4 of a circle. Okay. So if it completes 3/4 of a revolution in 3 seconds, then that means that 4/4 of a revolution, in other words, a full revolution, must take 4 seconds, right? Okay, aha, so now we know the period is 4 seconds. All right, what else do we know? We know the acceleration has a magnitude of 6 meters per second squared. And the problem wants us to know what the velocity is. And I also noticed that we don't know the radius. So what I'm now conscious of is the fact that we have 2 unknowns, right? We don't know the velocity of the ball, or, sorry, this camera's driving me nuts. We don't know the velocity of the ball, or, oh, it's because I'm looking at the wrong camera. Aha! Okay. So we have 2 unknowns. We don't know the velocity or the radius, okay? So let's see. So I know there's an equation that ties these guys together. AC is v squared over r. So for us, that means 6 equals v squared over r. All right? And then I also know there's an equation that ties these guys together, right? Because we're in uniform circular motion. That means I can just divide the circumference by the time it took, right? Because the speed is constant. So that means that v is 2 pi r over 4, which becomes pi r over 2. So I think if I take this top guy, I can solve it for v to get that v is the square root of 6r. Now I can combine these 2 dudes and set them equal to each other. So pi r over 2 equals the square root of 6r. Get rid of that square root by squaring both sides. So we get pi squared r squared over 4 equals 6r. So let's see. Let's multiply both sides by 4 to get rid of the fractions. So now we got pi squared r squared equals 24r. So one of the solutions is 0, right? So let's divide by r. So pi squared r equals 24. Oh, cool. So r is just 24 over pi squared, which means that r is, I once again lost the piece of paper that has it, so I'll just grab my calculator. 24 divided by pi squared gives us 2.43 seconds, or 2.43 meters, sorry. And so now I can plug that back in to find my velocity, right? And so, let's see, times 6, square root 3.82 meters per second. Okay, so there we go. But you got to be careful, because this is just the magnitude of the velocity, all right? Both of these equations here are for the magnitude of the velocity. So now we got to find the direction. So we're trying to find the velocity after 5 seconds. And so it looks like when it's at this point, remember the velocity is always perpendicular to the radius, perpendicular to the acceleration. So it's just going to be this way, negative 3.82 I meters per second. All right, there we go.